Good afternoon, everyone. Good afternoon. Hope all is well. Everyone's doing all right. It's only 1:29, so we'll give it a few minutes before we get started. Oh yeah, hope everybody had a great spring break.
Hello.
Yes, sir.
I think I need to leave and join again. This might be the wrong account.
Okay, not a problem. Not a problem.
Do you do touring?
Yeah, I have office hours. Yep. Did you can you make any of my office hours? Have you seen those hours scheduled?
Where we go see?
They are in if you look at Canvas announcements, I sent you a link or an email. It's entitled Office Hours, and it has your links and the times that I'm available. All right, looks like we are ready to rock. So, once again, good afternoon. Hope everybody's doing all right. Hope everybody's doing great. Like I said, hope you had a great spring break. Ready to get the rest of the semester started. We're on countdown time now. So all we have is 8 weeks left. You know, every time a week go by, closer we get into closing this thing out. So most
Is
definitely.
Friday a good time for sorry to interrupt, but is Friday a good time for tutoring?
You said Friday?
Yeah.
Yeah, if you're trying to come in at a 9 o'clock hour. If not, then we'll have to look at another time.
Okay.
All right. Okay.
Oh wait, it's gonna be a Zoom meeting. It's gonna be a Zoom meeting.
Yeah. Yep.
I'll come in about 9 or 9:30.
Okay, that's fine. All right, all right. So in chapter 7, remember last time before we left, before we closed out and went into spring break, we had we knocked out 7-1. So we're looking at 7-2 today. If I'm not mistaken, if I remember correctly, 7-2 is not a long section. But there's no rush either. So it's not like I have to jump into the next section today. So I'm just gonna do 7-2 as you guys get back into your flow. That spring break may have put a pause on. So we won't necessarily have to hit it running today, but we'll at least get 7-2 in. I know in math lab it says 7-1, 7-2, 7-3, 7-6, 7-7. So I don't, for some reason, I don't have my notes for 7-3, and I think my last class I didn't do 7-3 for some reason. So I need to check that out. Maybe we'll do 7-3, maybe not. We'll see. I most definitely will have an answer for you by next class. See why I kind of pushed off 7-3, but I know we'll do 7-1, 7-2, 7-6, 7-7. And like I said, we'll see about 7-3. But this is 7-2. 7-1 was law of sines. 7-2 is law of cosines. So we have a squared. And remember, lowercase letters are your sides. Capital letters are your angles. So notice in this case, we're looking for side A. We can solve for side A by having side B and side C, and then angle A. So it's a squared equal to b squared plus c squared minus 2 times bc cosine of a. And so that will be the flow for all of them. Notice if you're looking for side B, have side A and C, and then angle B, and then C will be on the left, AB, and then angle C. All right, so you people just came in, so I'll give everybody a chance to copy before we scroll up. All right, let's scroll up a little bit. So solving side angle side, that's what SAS is, a side angle side triangle. In other words, that's the given information that you have. You have two sides and the included angle. So we're going to use the law of cosines to find the side opposite of that given angle. And that's what I was talking about in the relationship that he gave. And once you do that, then you can use the law of sines, which is what we talked about in 7.1, to find the angle opposite of the shorter of the two given sides. So notice we're going to find the shorter one first. All right, scrolling up some. And so notice that last statement, this angle is always acute. Done with the first statement. And then we can find a third angle by subtracting the measure of the known angles from 180. Where all the angles in your triangle add up to 180. All right, let me scroll up. All right, so first example, in this section, solve the triangle with angle A 60 degrees, side B is 20, side C is 30. And in red, which is me reiterating what we have and what we do not have. Scrolling up some. So first thing we'll do is use the law of cosines to find side A. So we plug in the given information. We use a squared equal to b squared plus c squared minus 2bc, cosine of capital A, which is angle A. So that'll be 20 squared plus 30 squared minus 2 times 20 times 30 times cosine of 60 degrees. Scrolling up some. And so that would have you, or give you, a squared is equal to 700. And then you would take the square root of both sides. And that'll give you 26.5. So now, MathLab will let you know how many decimal places, as always. I just did 0.5. MathLab will let you know. Don't forget to keep your, when you're doing your calculations, have your degrees, have your calculator in degree mode versus radian. So notice the little note that I put on the right. So keep in mind, A was actually the square root of 700. So that's what I would use to find my other values. If I use 26.5, every time I apply an operation to that, I will get further and further away from the exact answer because it's truncated at 0.5. or the 10th place. So when you do your calculations, you will use square root of 700 to get the most accurate answer possible. So, all right. So everybody's clear what we got going on here. Anything I've said, make sure we're all right. Once again, they may want this as your answer, but when you go to calculate to find the other values, you use the square root of 700. Let's see, anything else I need to say before we go to. Also, don't forget, whenever you take the square root of both sides, square root of property always gives you the option of plus and minus, but we're dealing with measurement. So there's no such thing as a negative measurement. So that's why I didn't even write that or consider that when we took the square root of both sides here. I think we're good. Okay, so remember, if we go back to our steps, first step is to use the law of cosines. Second step is to go back to your law of sines out of 7.1. So now we have side A and angle A, and we can use this to find angle B. So sine A over A equal to sine B over B, law of sines. Plug in the values that you know. Notice what we have sine of 60 degrees, then on the bottom, there's that square root of 700 equal to sine of B over 20. And you know, if I were to erase everything as to how it was, that's how it would be initially. And then we want to solve for B, capital B, so we'll multiply both sides by 20. And so that'll be 20 sine of 60 degrees over the square root of 700. Take sine inverse of both sides. Notice how I put that in the calculator like this. That is the way you get the most accurate answer. But you know, depending on the type of calculator you have, you may have to use the decimal value. If you do decimal value, you cannot do 26.5. You do need to take the decimal out some, maybe 4 or 5 spaces to get a more accurate answer for that square root of 700. But we get 41. If I'm not mistaken, if you're leaning on the directions that we did last time, remember they asked us to round our degrees to the nearest degree. So that's why I'm pretty sure this wasn't an even 41, but we rounded it to the nearest degree. Once again, make sure you're paying attention to the directions that MATLAB, asked of you. All right, questions before we go to the last piece of this problem? All right, so then we can find C by subtracting A and B from 180. Let's see, it would be 79 degrees. All right, questions before I scroll up to the next one? All right. All right, so make this a little better. So now, instead of solving a side angle side, we're looking at solving side, side, side. And remember that this is reference to what they're giving you as far as the information initially. So first step is to use the law of cosines to find the angle opposite of the longest side first. Then once again, we're going to lean on the law of sines. In this case, it doesn't matter which side we find next or which angle we find next. We'll use the law of sines to find either of the remaining acute angles. And then same last step, we'll subtract the two known angles from 180 degrees. Is everybody good? All right. So next example, we have our three sides. A is 6, B is 9, C is 4, and we do not have not one angle. So, all right. So now going back to your directions, remember we're supposed to find the longest side first. I mean, not the longest side first, find the angle opposite the longest side first. So our longest side is B. So we will solve this for angle B. And this is just me running through doing so. So we start off with B squared equal to A squared plus C squared minus 2AC cosine of B, because that's the only one that had angle B in it. And once again, that's opposite the longest side. Side B was the longest side. So I just went ahead and solved it for capital B by subtracting A squared and subtracting C squared. Then you divide by negative 2AC. So don't forget that negative is right there. So make sure you don't lose it. All right. So here, A squared plus B squared, A squared plus C squared minus B squared over 2AC is just me getting rid of the negative denominator. You could have left it like this if you wanted. It's not a big a deal. As long as you hold on to your negatives accordingly. Decided to go ahead and plug in the values. 6 squared plus 4 squared minus 9 squared over 2 times 6 times 4. All right. Simplifying that gives me negative 29 over 48. All right. Then apply cosine inverse to both sides. B is going to be 127 degrees for us. All right, everybody okay with B before we go to the next step? So now we use the law of sines to find either one of our other missing angles. Remember, in this case, it doesn't matter which one. So I decided to find A. So you sine B over lowercase b equal to sine A over lowercase a. Plug in the values, a sine of 127 degrees over 9 equal to sine of A over 6. Multiply both sides by 6. Sine A is equal to 6. Sine of 127 over 9. And apply sine inverse to both sides. A is equal to 32 degrees. Mhm. So then from there, we have capital A and capital B are angles, A and B. Subtract both of them from 180, that'll give us 21 degrees for angle C. All right, questions before we go to the next one, make sure we're okay. So I think this is the last new piece of information, a new formula in this section, Heron's formula for the area of a triangle. So remember, the area of a triangle is 1/2 base times height. So this is another way to find the area of a triangle. All right, so the area is going to be equal to the square root of S times S minus A times S minus B times S minus C. And S is equal to 1/2 times A plus B plus C, which just reminding you that A plus B plus C would be the perimeter. So 1/2 the perimeter. All right, so we want to find the area of the triangle with 12 yards, with A being 12 yards, B being 16 yards, and C being 24 yards. Mhm. So first thing you want to do is find S. So it's 1/2, 12 plus 16 plus 24. So 52, we add them together, have 52 would be 26. Now that you have S, you can go ahead and plug into the formula. If you want to do a step-by-step like I did here, then that's fine, but good, throw it in the calculator. You know, right here. Square root of 26. Use your parentheses correctly. You should be all right. Square root of 26 times 26 minus 12 times 26 minus 16 times 26 minus 24. Depending on your calculator, you may have to put a parentheses around, you know, the whole thing. You know, it just depends on the type of calculator you have. And so 26 times 14 times 10 times 2, 7280. Square root of that will be approximately 85 yards squared. All right. Questions? Any questions on that? I think that, yep, that's it for that section. All right, questions on anything I've said, processes, procedures? Good, straight. So, like I said, I wasn't going to hit you guys too hard today. Trying to jump, you know, a whole bunch of sections. I think 7.2 was good enough to get us back into a math flow coming out of spring break. Next class, we'll either do 7.2 or 7.6. Like I said, I have to see why I didn't do 7.3 last class for my last class. But you know, if I didn't, that means it's not that big a deal if we do it or not. So, but 7.6 most definitely will be one of the things that we are going to cover. 7.6, 7.7. Oh, also don't forget, remember we haven't taken a proctored test yet. We talked about before spring break that chapter 7 and chapter 11 need to be proctored. So, you know, I don't mind you using notes or a sheet that you generate with procedures and all the stuff like that. So if you want to flow like that, that's fine. I just, you know, prefer you not use a whole other person. You know what I mean? So as long as you're not using another person, I'm good with you. But if you want to start looking at how you would generate your, whether it be a sheet or at least having your notes in a organized manner so that you can be able to flow through them throughout the test time, because it will be during the test. So that will be something that is timed. I will present an opportunity for a makeup that will happen after test time. But we'll talk about that as we get closer to doing it. But yeah, yes, that's how we'll flow. Questions, concerns, comments before we close today? Everybody good? Everybody straight? Like everybody's good. All right. So that's the case. You guys have a good one. Be safe, and I will see you guys next class.
I'm sorry. What
Take
test
care.
are you talking about there?
Chapter 7.
The third-
The stuff that we're talking about today.
Okay.
That test will actually be
This one
proctored.
we proctored.
Mm-hmm. Yep.
Okay. I sent you an email about chapter 6. I didn't get some of the work done. I missed the
Okay.
test.
Okay.
Pearson's locked me out.
Yeah. I'll respond to that today.
Yeah, I can get that this week.
Okay.
Thank you.
Yeah, that's not a problem. All right.
I
You have a
sent
nice day.
an email as well.
Okay. 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 Talking about the same things.
Pretty much,
Me too.
yeah.
Okay.
Yep.
So
Yeah.
I see another hand go up. So what y'all telling me is y'all didn't get the work done. Y'all supposed to work through spring break. No, it's all
No.
good.
And no excuse either. I just didn't.
I did the work over spring break.
I'm understanding things okay though.
Yeah, it's
You're
not a
doing a
problem.
good job.
I'll just do a general extension for everybody
Yeah.
since I'm seeing multiple hands go up. I saw you, Mr. Chris.
I did the work. I did the work over spring break.
Oh, you did? Well, good job, sir. Good job.
Good job.
But yeah, I'll just do a general extension for everybody. And hopefully that'll
Thank
be good
you.
for you guys. Yeah, not a problem. Not a problem.
You have a lovely day.
All right, you take care.
We're done?
Yeah, that's it for today.
Okay, bye.
All right,
That's
take
early.
care. All right, take care.